Hello, this is Simadi, and today we are going to learn about isomers, but in a fun way. Well, isomers are compounds that have same molecular formula but are structurally different. And do you know that we work with isomers every day, pretty much every day in our real life? So, for example, if you look at what are isomers in our real life, it's like designing your home. Hey, do I want this area of like a kitchen right next continuing to a living room, or do I want my living room as a square and a kitchen adjacent to it? Or it could be as simple as, hey, I have a table. Do I want it straight like this, or do I want it in a cross like this? So that also is a part of isomers. So if we apply isomers to our real life, it makes studying isomers very easy. So isomers are classified into structural isomers and stereoisomers. The stereoisomers are also called as spatial isomers. So the structural isomers are further classified based off chain, position, and functional group, while the stereoisomers are classified based off enantiomers and diastereomers. We will learn about stereoisomers in my next video, but in this video, we are just going to focus on structural isomers. So the structural isomers, um, before I go into the structural isomers, let me talk about something. Here are their way how they look in the chemistry perspective. So the structural isomers are like where they're located or how they're structurally or positionally different, while the stereoisomers are based off they're located in the same place but how are they oriented in the space. So, but I will go into the stereoisomers in a very detailed way in my next video. But today we are going to learn about the structural isomers in detail. Now, if I apply isomers into our real life, so how are the structural and stereospatial arrangements are going to look like? So, if you look at the structural isomers and spiral isomers, this is how just now I went over them, but here are the way they are shown. If you are living in 100 square feet, the structural isomer is like you are splitting the kitchen to show where it is located, while stereoisomers is we are keeping the space the same and the same structure, but just the way they are oriented in the space is going to be different. So coming to our structural isomers, as I mentioned, it is a chain, position, and the functional group. So the chain, if you look at it, it's based off only the carbon chain, how they are oriented. And the position isomers are where we are focusing on the OH group, where it is positioned. And functional groups, here you see it's a carboxylic acid group, and we are changing it into an ester group. Well, this is how we learn. Can you tell us something different? Oh, well, let's learn it something different in our everyday life. So the chain isomers, it's like we already know there is an area 1 and area 2. And if you see, this is an L shape and became a V shape. But if you see, the area is the same, which is same like saying that chemical formula is the same, but they become a completely a different structure based on how you want to keep them. So see here, it is a hexane, but moving this carbon chain or only one carbon to the second carbon made it a 2-methyl hexane, but the chemical formula is the same. It's like having the area 1 and area 2 are it's where I want my area 2. I know that I want them next to each other. I want it on the same carbon chain, but how are they located changes. So this is what is called as a chain isomer. Coming to the position isomer. So here we are focusing only on the OH position. Here the OH position is on the second carbon, but here it is on the first carbon. It's like we were talking about 30 square feet. Do you want it here or do you want it here? So the location of the 30 square feet is what we are focusing on. So that is the OH group. Next, coming to the functional group isomerism. It's like remodeling the whole house. So if you look here, there was a wall and it was not very open. But here, once we removed the wall, it became an open kitchen. It's the same principle. Like, although the chemical formula is same, by just changing the hydrogen here and rearranging the molecule, it became from a carboxylic acid to an ester, and the whole properties change. So this is what are structural isomers, where we are not saying, hey, is the OH is in the front or the back. We are just saying, hey, it's not on the same carbon anymore. So this is what is about structural isomers. In the next video, we will learn about spatial or stereoisomers. When we apply the stereoisomerism to our real life, how it's going to look like. Thank you. Bye.